And remember, this was saying, hey, we're dividing by this base. So really, this is 1 divided by a half, which is 1 times the reciprocal, which is just 2. So here, 1/2 to the negative 1 is equal to just 2. So that's our point right there. -1, 2. That's that. That's how we're just taking each of these off that table and we're just plotting them as points as we figure them out. So now I'm going to go 1/2 to the negative 2, and that's 1 divided by 1/2 squared. 1/2 squared is a quarter, so 1 divided by a quarter is going to give me 4. And then here, if I put -3 in, 1/2 to the negative 3rd, that's 1 divided by 1/2 to the 3rd. We know 1/2 to the 1/2 to the 3rd is 1/8. 1 divided by an 8 is 8. So 5, 6, 7, 8. All right, where this is 5, 6, 7, 8, 9, 10. So here we get this function. Or sorry, this is our function. We get this graph. So our graph looks like this. As we go this way, as x gets larger in the positive direction, our graph approaches 0, right? These numbers go like 2, 1, 1/2, a quarter, and 8. Next one would be a 16th. Next one would be a 1/32. That denominator is doubling in size while the numerator stays 1. So we're getting closer and closer to 0. So once again, we have this asymptotic behavior, but it's on the other side of the x-axis. So here we still have an asymptote at y equals 0, saying that our function, or our outputs, are getting closer and closer and closer to 0, but never quite getting there. And then on the other side, as x's go negative, these negative numbers are dividing by 1/2 over and over and over again. And then, well, dividing by 1/2 is the same as multiplying by 2, so they're just doubling in size. So we're going to get larger and larger this way. So here we're going to get, actually, if we look at these graphs, both of them extend left and right. Both of them have an asymptote at 0 and go up. So they're going to have the exact same domain and range. The domain is going to be all real numbers. Because we can input any value in for x and then make that number the exponent have a 1/2 that many times, or divide by 1/2 that many times. And then the range, once again, is going to be y is greater than 0, because we get all these positive numbers, and as we go to the right, as our x numbers get larger and larger, we're going to approach 0. Our values are going to get smaller and smaller and smaller, but they're going to stay above 0. So what's kind of cool here, maybe you noticed this, these graphs are very, very similar, right? They're just reflections of each other, reflections over the y-axis. And based on this, right, the fact that the negative exponent, if I have n to the negative, let's say it's a to the negative n, that's the same as 1 over a to the n. Once again, when a is not equal to 0. So if I take 2 to the negative x, remember this negative is going to be a reflection over the y-axis, right? That's equal to 1/2 to the x. So this function, this 1/2 to the x, is the same as this function to the negative x, right? Or the reflection there. All right, so that's how we graph those. I'm going to talk a little bit about just graphing b to the x. So if we replace this with just any value. So I'll let that here, switch to the next slide, I'll erase it, and then we'll go. Okay, so we are now extending a little bit further. Instead of saying 2 to the x, we're going to have b to the x, where b is just some number. In this case, it's greater than 1. So it could be 3. It could be 3 to the x. It could be 5 to the x. It could be 1.5 to the x. It could be 1.01 to the x. Whatever. Just some number bigger than 1. All right. So if I was going to make a table, hang with me here, x and f of x equals b to the x, it's going to follow these same properties. So b to the 0 is going to equal 1. So I'm going to have 0 for my x, 1 for my y. That's my y-intercept. The y-intercept is always 0, 1 if it's just b to the x. Once we do some transformations on that, that y-intercept will change. But for now, it's right there. Now, if I make x 1, what I do is this is b to the 1. So this is just b. So here, it's at 1, b. Whatever that is. I'm not making a scale here because I don't know what b is, but it's going to be 1, b. I do know that if I multiply by something that's larger than 1, my answer is going to be bigger. Like if I take 1 times something bigger than 1, my answer will be bigger than 1. Let's get rid of this. There we go. All right. So now if I put 2 in there for my x, I'm going to get b squared, or b times b. It's this previous one times b. So now if x is 2, I'm going to get 2, b squared. And then if I put 3 in for x, I'm going to get b to the 3rd, which is b times b times b. Or in other words, I'm taking this and multiplying it by b again. So 3, b to the 3rd. So this graph as I go to the right is going to be, it's going to have this curve. The bigger this base number is, the bigger this b, the steeper it will be. The smaller that number is, the closer to 1 it is, the flatter it'll be. It'll always kind of tend to curve steep up the farther out you get toward, the bigger x gets. But for small x numbers, if that b value is like 1.01, it's going to look fairly flat. If that b value is like 10, you'll have like 10, 100, 1,000, it'll get really steep really quickly. So what I want to show you here is as x goes plus 1, the y value goes times b. And this is as x goes plus 1 times b. It's the previous value times b. And when we do transformations of this, you can think of it as this is the distance from the asymptote. In this case, the distance from the asymptote is just the value. If I were to shift this up or down, I would still be multiplying my output by b again, but it would be that output, the distance from the asymptote, not the y value. So that's going to change a little bit when we do transformations. Right now, it's just as you add one value to the x, your y value gets multiplied by your base again. So instead of having a slope of like change in x over change in y where it's constant, right? We have a change in x of 1. Our change in y is now a multiply, not a plus, but a multiply by. And then as I go this way with my negatives, here, if I have -1, this is b to the -1, which is 1 divided by b. So here I'm dividing by the base number. So my numbers are getting closer to 0 because this is larger than 1. If I take 1, divide it by something bigger than 1, my answer is smaller. So if I have -2 and -3 as my x's, I get b to the -2 and b to the -3rd, which is 1 over b times 1 over b. In other words, I take this and I divide it by b again. And if I divide it by b again, it's getting even smaller. So here I have -2, 1 over b squared, or 1 divided by this value. And then here, b to the -3rd is 1 over b times 1 over b times 1 over b, which is this one divided by b again. So it's getting closer to 0. So I get this same shape. The same shape that I get for 2 to the x, but the steepness, how quickly it approaches 0 and how quickly it shoots straight up, depends on how large or small this b value is. But as long as this b value is bigger than 1, this is going to represent exponential growth. And it's growth because as x gets bigger, the y values get bigger. So once again, we're going to have our asymptote is at y equals 0. The asymptote's at y equals 0, because here, as I keep dividing by this number that's bigger than 1, I get 1 positive divided by positive. It's still positive, but it's getting smaller and smaller and smaller, so it's getting close to 0. The domain is all real numbers. I'm abbreviating here. And the range is y is greater than 0. All right, we're going to do this one quickly, because I know you're probably getting bored of watching this video. Hope not, but let's be honest. Probably are. All right, so we have b to the x, where b is between 0 and 1, so this is like a number like a half, or 0.1, or 0.6, or 0.9, or something like that. Some number that's positive, but between 0 and 1. So the idea here, and I'm not going to do the table, is that if I take, so I'm going to have 0, 1 again, but now 1 times b, where this is smaller than 1, because we're saying in this case that b is less than 1, is going to be smaller than 1. So when I graph this, when x is 1, then b to the 1 is a number smaller than 1, so it's down here. And then when x is 2, b squared is going to be smaller than b, because I'm taking a number and multiplying it by something smaller than 1. Like if I take a number and multiply it by a third, it's a third the size that it used to be. So here we're approaching 0 on this side, just like we were with that 1/2 to the x. And if I take b to the negative 1, that's 1 divided by b. If I go 1 divided by small, in case smaller, like in this case smaller than 1, this is going to be